Hello everyone. I'm Dr. Isha Mehra from ABES Engineering College, Ghaziabad. I'm going to talk about the unit fiber optics and laser today. In the last part, we have covered types of transitions, and further I'm going to tell about these transitions and types of lasers. In the last part, we talked about the types of transitions, that is spontaneous and stimulated transitions, absorption. So we have already in detail studied about the probabilities involved in absorption, spontaneous emission, and stimulated emission. Also, we talked about Einstein coefficients. We have derived the probabilities and the ratios regarding these Einstein coefficients. Like we talked about A21 upon B21, we have found this, it was proportional to UQ, mu Q. And also we have derived that B12 was equals to B21. That is Einstein coefficient of absorption is equals to Einstein coefficient of stimulated emission. These are Einstein coefficients. These are Einstein coefficients. We also talked in detail about the Boltzmann distribution law, and also we have used the equation for the Planck's law. Now we are going to move further, and we are going to talk about the types of lasers. There are various types of lasers here. So we are going to talk about the ruby laser and helium neon laser, 3-level laser system and 4-level laser system. But before that, we are going to talk about very important terms. We can say 3 components or essential components which are involved in laser. 3 components or essential components of laser, or we can say functions of laser. So in this case, the 3 important parts, the first part is the pumping source. Or instead of pumping source, we can say active medium. First, we are going to start from active medium. This active medium is nothing, but it is the number of atoms, or we can say number of ions, which needs to be excited from ground state to excited state. If there are no number of atoms, there are 0 number of atoms in the ground state, then how they can jump up and how we can incident some energy upon it so that they can be raised up to the higher energy level. This means there must be the number of atoms or ions which should be present in the ground state. So active medium is basically, we can say, group of atoms, group of ions, which needs to be excited such that the emission, the stimulated emission should take place. Now, how we are going to excite these atoms which are already present in the ground state? For this, we need a pumping source. This pumping source can be optical, it can be electrical, it can be chemical as well. So pumping source means how we are going to pump, how we are going to push the atoms so that they can be raised from ground state to the higher excited state. And the last part, the third component, is almost the same component which is applied in every kind of laser. That is the pair of mirrors, which we say as the resonator, optical resonator. These are the pair of mirrors and they are given name as optical resonator. On one side, it will be completely reflecting. And on the other side, it is partially reflecting. Partially reflecting will be on that side in which the beam output is there. The laser light output is there. So what is its function? What is the function of optical resonator? Its function is to amplify, or we can say multiply the number of photons Now multiply the number of coherent photons, which are very much required for the laser, large number of coherent photons, so that the intensity can be increased. So every component plays a very important role in this case. So we are going to start with a laser that is a 3-level laser or a ruby laser. So 3-level laser or a ruby laser also, we are going to use all these components because these are essential components. So when we talk about ruby laser, we can say it is a 3-level laser. It is also called as solid state laser. So this ruby laser is a 3-level laser. Now again, we are going to describe its construction as well as working. So when we are going to describe its construction, again we have to talk about all the 3 components. So what are those 3 components involved here? One is the active medium. Now what is this active medium here? In this case, ruby laser, we use a ruby rod, and that ruby rod should be having some chromium ions doped in it. Means the active medium will consist of, we are going to use a ruby rod. This is a part of active medium. We can say it is Al2O3, which is doped with chromium ions. That is, how much percentage of chromium ions? It can be 0.05% of chromium ions. We can write it as plus Cr3 plus ions. Some amount of chromium ions are dipped in this, 0.05%. So the important part of this is the chromium ions plays a very important role in de-excitation, or we can say in the emission part. In this case, the further part is the pumping source. Now, how the pumping source? In this, we provide optical pumping. Optical pumping means we are going to use some light source. Now, how I can use some light source so that evenly, uniformly, from every side, equal amount of photons can reach these chromium ions and can excite these chromium ions. This can only happen when we are going to place a lamp, which is called as xenon flash lamp, around this in helical form. If it will be placed in helical form, then uniform amount of photons, they are going to come and they can give their energy to the chromium ions so that these chromium ions will be excited. This is a power source. And this can only be done if we are going to place a glass rod in this. It is very much required. Glass tube is very much required, because how we can place then the source, or we can say the lamp, in helical form. So it will be like this. It will be a glass rod. Now the third part is the optical resonator. One part will be completely reflecting and other part will be partially reflecting. One part will be completely reflecting and other part will be partially reflecting. So we can write this here. This is fully reflecting and this is partially reflecting, from where we are going to get a very good amount of coherent laser beam through ruby laser. So partially reflecting surface of the lens will be there. Now, the problem is in this, it heats up very quickly. Ruby laser has this problem that it heats up very quickly. So what we are going to do, we are going to apply a water system, water inlet and water outlet. So the water, when it is going to circulate through its boundary, So it is going to cool the system. So the heating effect will be less, although it will be there, but the heating effect will be less. So in construction, what we have used, we can write it over here. We have used an aluminium rod Al2O3, which is doped with chromium ions, Cr3 plus ions, few chromium ions, we can say. The other part is the optical pumping. And optical pumping, we have provided with xenon flash lamp in helical form. Helical is very important so that equal number of photons can go and incident with equal amount of energy on the chromium ions. So in helical form. And the third one is resonator or optical resonator. That is pair of mirrors. One is completely reflecting and other is partially reflecting. This helps in amplifying the number of photons, the number of coherent photons. Now, when we talk about its working, so let's look in this diagram. I already told that this is a 3-level laser. So we are going to draw 3 levels, E1, E2, and E3. There are 3 levels, E1, E2, and E3. So in this case, the chromium ions are by default in the ground state, Cr3 plus ions. Initially, they are in the ground state. When through helical xenon flash lamp, the photons are going to come and they are going to incident on this chromium ions. So these chromium ions are going to pumped up. So this is happening through the xenon flash lamp, which is having the wavelength of 55, almost 5500 angstrom. And we can say this is a pumping transition. Or we can say this is the optical pumping or pumping transition. So the chromium ions now they are in the higher excited state E3. In case of 3-level laser, this level is a short-lived level. This is a short-lived state of the order of 10 raised to the power minus 8 second only. So the chromium ions will go and they will suddenly come from E2, from E3 to E2, resulting into radiation-less transition. Why radiation-less transition? Because in this case, the photons which are scattered here and there, they are going to die and they're going to collide with the walls of the active medium. So there will be not anymore. There will be no radiation. There will be no output here. Now the chromium ions, which are here in the E2 level, this state is a metastable state. And if this is a metastable state, then this is a long-lived state. It is a definition of metastable state that it is a long-lived state and it is having a lifetime of 10 raised to the power minus 3 seconds, which is quite higher as compared to the 10 raised to the power minus 8 seconds state. So the chromium ions, they are going to stay here for a while. And they are going to stay here for a while. And when a condition of population inversion is achieved. What is this population inversion? It is a situation in which the number of atoms in the upper lasing level will be greater than number of atoms in the lower lasing level. So a lot of chromium ions which are present over here after the state of population inversion is achieved, they are going to drop down. And when they are going to drop down, they are going to emit the wavelength, the coherent beam of wavelength 6943 angstrom. So in this case, 6943 angstrom, the photons, they are going to multiply. They are multiplying because of the optical resonator. How they are multiplying because of optical resonator? Let's have a quick look here. When the atom is by default in the E2 level, excited state. So do you all know what is stimulated emission? I have already explained it in my previous video, part 1. In stimulated emission, I already explained when the atom is there in the excited state. So an external photon is going to come and it will be incident on this atom which is there in the excited state. And when this atom is going to drop down, it is going to emit 2 coherent photons. So from where this is external photon is coming? This external photon is coming because of the optical resonator. There are a lot of photons which are traveling back and forth here. So in this case, the photon which is along the axis of this medium, it will come back, it will bounce back because this is partially reflecting. So it is going to bounce back, and when it is going to bounce back, so it is going to result in the stimulated emission because of this photon. This photon results in the multiplying of the coherent atoms because of the stimulated emission. So that is why we have seen that instead of 3, it is 4, then it is going to multiply, and we are going to get a very high density laser beam from a ruby laser of wavelength 6943 angstrom. Only the problem in this case is this laser heats up very quickly. So we need some arrangement to quickly lower its temperature for the proper functioning. So if we talk about characteristics of ruby laser, so its power output, these are standard specifications, is 10 raised to the power 4 to 10 raised to the power 6 watt. If we talk about its frequency, it's 4.32 into 10 raised to the power 14 hertz. And the output in this case is the pulsed output. While in case of other lasers, we are going to talk about how the quality of that output is. Is it pulse or it is continuous? But in this case, it is a pulsed output like this. Why it is pulsed output? The pulse output here is because the input we have given from xenon flash lamp is also pulsed. That's why we are getting the output in the form of pulsed. So these are the ruby laser construction and working. 3-level laser, and the pumping source is the optical pumping through xenon flash lamp. These are the references. In the next part, we are going to talk about the helium neon laser, which is the 4-level laser. So it will be quite different as compared to ruby laser. Thank you for your patience listening.